Okay. Is that pretty good? Yeah, I'll do. Alright, so, funny thing. So, after I, put play, for some reason my camera didn't have enough memory. So, even after I explained everything, it kind of shut off. So, yeah. But I know it stopped, right when I was about to draw this graph, right? So, let's just continue off from there. So, it took me a while to draw it, but I eventually did. So I figured out that, well, y equals x, that was a simple one, right? F of x took me a while, but it's just negative x squared plus 2, so I shifted up 2, and it's a negative parabola. And then I found my intercept points, right? So negative 2, 2, that's where it intercepts. Because at negative 2, y equals negative 2. I deleted my work, but it was 2 minus negative 2 squared, which turns out to be 2 minus 4, which turned out to be negative 2, right? And y equals x, when x equals negative 2, y equals negative 2. So that's an interception point. The other interception point was 1, 1, because over here, if 2 minus 1 squared just turns out to be 1. And then over here, when x equals 1, y also is 1. So that was our other interception point. So we were trying to find the area in between. And then I just gave the tip to not forget about your representative of a rectangle. And then after that, we used the equation that, remember that we knew, integral from a to b of the top function minus the bottom function dx. This is where drawing the graph really helps, because you're going to be able to see which is the top function, right? So we know f of x minus dx, and then you just plug in what you know, right? So your lower limit was negative 2, your upper limit was 1. So, and then f of x, you just copy paste from over here, and then g of x, copy paste. And then from there, then was the messy work, the algebra that we had to figure out. So over here, I just simplified, right? Negative 2 to 1 of negative x squared minus x plus 2 dx. Then I found the antiderivative, right? So negative 1/3 x cubed minus 1/2 x squared plus 2x. The limits stay the same. And then after that, I just did b minus a. So plugged in 1 for x, then plugged in negative 2 for x, subtracted. Over here, it looks kind of weird, but what I did is I found the common denominator, right? And then I added them up. Found over here, found the common denominator of 3. Over here was 6, right? Added those up. It turned out to be 17 over 6 minus 26 over 3. The common denominator is 6, so I times this by 2. 52 over 6. Over here I subtracted 17 from 52. Or 17 from, subtracted 52 from 17. There we go. And then I got negative 35 over 6, right? But you have to know that the area between two curves, or the area itself, is always positive, right? So you just take out the negative sign and you leave it positive. And then that's literally it. It's super easy. Just to recap, remember, first draw your graph. Helps you visualize it a lot. Even though you're gonna like, oh, why do I have to do this? Do it. It really helps. Draw a representative rectangle, and then just plug into the equation over here, lower limit, what am I talking about? Integral of a to b of the top function minus the bottom function. Then just plug in your data points, and then after that is just ugly algebra 1. And that's about it. So really, pretty simple. And thank you.